So this is a relatively short segment on dew, and then actually if the temperatures are cold enough at the Earth's surface, instead of dew we get frost, because what they both have in common is that objects on the Earth's surface, or I should say the Earth's surface basically has become 100% saturated, 100% relative humidity, or the air's become saturated with water vapor, 100% relative humidity, and you go ahead and get condensation in the case of dew, and actually what we call deposition, or sublimation, sometimes what the term used, when water vapor goes straight to a solid in the case of frost. So it's just basically what we've been talking about. Both dew, formation of dew and both the formation of frost count on the Earth's surface cooling down over the course of the night as we have nighttime. And in that case, they're counting on that radiation process that I talked about when I talked about the formation of radiation fog. So, what this slide does to remind you then is that clouds would kind of act as a blanket and sort of stop the radiation process, and so you won't get those cool temperatures that you might get that give you dew and frost. And then along those lines, trees actually can kind of serve as the same purpose. So underneath trees you aren't going to see dew and frost form. Objects that cool down quickly, like cars and things like that, that's where you see where they cool down quickly, that's where you're going to see them reach what we call the dew point temperature. So I mentioned that I think that frost is so cool because frost counts on basically water gas, water vapor, going from being a vapor. What frost is a solid, so it skips the liquid state. And it definitely is a doable sort of thing depending upon the temperatures and the water vapor pressure and all that. So we call that deposition basically. Dew point temperature is the temperature that air needs to cool down to in order to get those water vapor particles to go ahead and condense and liquefy, cool down such that they can go ahead and form those intermolecular bonds and become a liquid instead of a gas. That's dew point temperature. So frost point temperature, then, would simply be the temperature at which deposition will occur. Remember, deposition, I think, is the preferred term aside from sublimation. Deposition is when water goes from being a vapor to being a solid. So dew point temperature, frost point